So, starting this lecture with integral, uh, in this question we are having cos square x as a denominator. In this type of question, what we do, at first we try to separate it by 1 by cos square x minus sin x by cos square x. On shifting this, we are getting 1 by cos square x. We can write it as sec square x, and this one would be tan x and sec x dx. So using the indefinite formula for this sec square x, as we can write it as tan x, after that this would be sec x plus c. Okay, now moving to the next question. In this question we are having uh, a matrix, and we need to find the value of x, as this would become a skew matrix, or it is already a skew matrix. To do so, we will recall the formula of skew matrix. It is state the transpose of the matrix will equals to minus times the magnitude. So finding transpose of this, at first uh, finding transpose is very easy, as the formula suggests us to exchange the row into column and column into row, or vice versa. So this would be 0 3 4 and minus 3 0 5, again x minus 5 and 0. Now minus a would be simply interchanging the sign of each element. We will get 0 minus 3 minus 4, 3 0 minus 5 minus x 5 and 0. Now on comparing this two matrix, we can say that x is equals to minus 4. Answer: x equals minus 4 by comparing the corresponding elements. Now again the integral quotient. This quotient 1 by root 1 plus sine 2x is the pattern 1 of basic trig. If you haven't know the basic trig thing, then you can find it on my playlist. That would be more beneficial for you to solve the differential calculus as well as the integral one. Now on using the formula for sine 2x, we can write it as 2 sin x and cos x. Again, on seeing this angle, one can be expanded into cos square x plus sin square x. As we can see, this is the formula of a plus b whole square. We can write sin x plus cos x, or we can use cos x plus sin x. The first presence should be cos x, as it is an even function. So I'm writing it as cos x plus sin x whole square. Now if we put 1 plus sin 2x as cos x plus sin x whole square, the root will get eliminated. Now if you want to calculate the integral for this, you can choose the either way, cos 2 theta method or sin 2 theta method. That will be convert the equation into the terms of tan, and after taking some substitution method you can solve it. I would rather try to find the value of this integral using the basic trig, which is the compound angle formula. Let's take root 2, as this one would be 1 by root 2 cos x plus 1 by root 2 sin x. Now we can write 1 by root 2 as sin 45 or cos 45. I want to express it as a let's say cos x and sin 45 plus sin x and cos 45. So this has turned this cos x plus sin x into a single trig of the expansion of sin a plus b, where I'm taking x as a and this one will be b pi by 4. Now this can be written as root 2 and sin x plus pi by 4 dx. So 1 by root 2 again this would be cosec x plus pi by 4. On using the formula for cosec, you will get your required answer. So moving to the next question, this question is of probability. In the question we are having two times of probability of getting A equals to probability of getting B equals 7 by 13, and probability of getting A when B has happened equals 2 by 7. We need to find the value of A union B. So at first what we'll do, as we can see, the conditional probability is given. So using the formula for conditional probability, this would be P A by B equals P A intersection B by PB. Now using the multiplicative theorem, we can see that in place of A by B we can write 2 by 7 times in place of PB we can write 7 by 13 equals PA intersection B. So after getting 7 cancel, we will get the value as 2 by 13. Now we need to find the value of A union B. On using the formula of the union, A union B is equals PA plus PB minus PA intersection B. On putting the suitable value, you will get the required answer. Okay, you can write PA as 7 by 26 plus PB as 7 by 13 minus 2 by 13. Okay, so the next question is about determinant. Many students finds it's very difficult to solve determinant as it requires the core concept of the factorization and expansion, and the critical thinking is also required. So in this question they have given the rows and column which are having the elements of x and y. Now we need to prove that this is equals to the product of x plus y plus z times z minus x to the power 2. At first what we do, we try to add or subtract some row or some column to get x plus y plus z or z minus x. Okay, so at first I'm trying to add this 3 column. On adding this 3 column I'm getting x plus 2y plus z. Okay, so in the coefficient of y we are having 2, which is not required, so this approach is not useful for us. Again I'm trying to add this 3 row. So on adding this 3 row I'm getting 2 times x plus y plus z as well as x plus y plus z. In column 3 I'm also getting x plus y plus z. This will be z plus x, x plus y, again z, y, x and z. On taking x plus y plus z common from the first row, the determinant will reduce into 2 z plus x, x plus y, again this would be 1 z, y, and this would be x, 1 x, and this will be z. Now moving to the next thing, we need to find z minus x. As I can see here, if we subtract c2 and c3, on writing c2 as c2 minus c3, we will get z minus x. And again if we will write c1 as c1 minus 2 times c3, we will get z minus x. Okay, let's see what we have here. We have x plus y plus z, x plus y plus z. Here we have 2 1 1, 2 1 1, again z plus x, x plus y, z plus x, x plus y. What we have, z y x z, z y x z. So on operating this, we will get c2 minus c3 as 0, z minus x and y minus z. So this would be 2 z plus x, x plus y, and this will be 0, z minus x and y minus z. This will remain as 1 plus xz. And if we apply c1 minus c2 c3 operation, then this one will also become what, 0 z minus x. Okay, 0 z minus x. So this would be 0 z minus x. Again, this would be x plus y minus 2z. Okay, x plus y plus z. As we can see, we have got 2 0 on row 1, so this is the time for our expansion. If we expand it as with respect to the row 1, then this will be plus, minus and plus as per the cofactors. Then this will be x plus y plus z. After that, this is what the multiplication, the z minus x times y minus z, minus, because the formula is this crisscross method. Okay, now this is z minus x again times what, x plus y minus 2z. So if we x plus y plus z, see z minus x is there and this is twice, then we can easily get z minus x as common. Then this will be z minus x, and this here we will live with 1 minus z. On multiplying or opening the bracket using minus as multiplication, then minus x and minus y plus 2z is there. So plus y and minus y will get cancelled out. After that, x plus y plus z, again z minus x, here we live with z minus x. So this was the required answer to prove. Thank you. So in this question we are having y equals e to the power sine inverse x and z equals to e to the power minus cos inverse x. This is the example of a implicit form. In this question we will try to differentiate y and z simultaneously, as y with respect to x would be e sine inverse x times 1 by root over 1 minus x square. I am using chain rule over here. The differentiation of e will remain as it is. The differentiation of sine inverse x will be 1 by root over 1 minus x square, and the differentiation of x is 1. That's why I haven't written it. Again, dz by dx is e to the power minus cos inverse x times minus root 1 minus x square, and we also are having minus 1 over here, so this will be e to the power minus cos inverse x divided by root 1 minus x square. Now if we divide this dy by dz, we will get dy by dx divided by dz by dx as e to the power sine inverse x divided by e to the power minus cos inverse x. Using the indices formula, if the base are same, then in division we subtract the angle, so this will be e to the power sine inverse x plus cos inverse x. Using the ITF formula, so this question is about ITF. We need to prove 1 by x square plus 1 by y square equals to 1, where they have given us sec inverse x equals to cos inverse y, cosec inverse y. So at first we will let it as sec inverse x equals cosec inverse y equals k. Then x will become sec k and y will become cosec k. Okay. Now if we reciprocal it, then we will get 1 by x as cos k and 1 by y as sin k. On putting the value, or say squaring and adding, we will get 1 by x square plus 1 by y square equals cos square k plus sin square k, and this will be one answer. Now moving to the next question. This is the question of relation and function, and they have given us the function as 3x minus 1, where x belongs to real number. We need to prove that the function is bijective. Bijective means 1 1 and on 2. Okay. So for 1 1 we will say, let's put x1 and x2. So 3x1 minus 1 by 2 equals 3x2 minus 1 by 2. Again, if we cancel it, then 3x1 is equals to 3x2. We will get x1 equals to x2. So this shows that the function is 1 1, because 1 1 means for every different input we will get the different output. Okay. So to find onto function, one can convert it into, let's say y is equals to 3x minus 1 by 2. Okay. So I'm trying to express this function in terms of x, then this will be 2y plus 1 by 3 is equals to x. Okay. So to prove this is onto means the range will equals to the codomain of the function. In this, the codomain is r, so the range must be r. That's why we will replace x by what, 2y plus 1 by 3. Okay. On replacing it, we are getting, say this one is 2y plus 1 by 3 minus 1, again this is by 2, so 3 and 3 will get cancelled out. Then 2y plus 1 minus 1 by 2 is there. On solving, we will get y. So we are getting what, we have got the answer as y. This proved as the range and the codomain are equal, then this one is as well as onto. Now they have told us to find the inverse function. Inverse function we have already calculated it. Just express it as f inverse x equals 2x plus 1 by 3. See, the question is 3x minus 1 by 2, we have equated with y, then we have completely changed the function in terms of y, so that will give us the inverse value. But on doing inverse, at first you will need to prove that the function is 1 1 and onto, which is bijective function, because if a function is not bijection, then the, then the function will never ever become the inverse function. Okay, thank you. Now moving to this question, the integration one, we can see there a lot of e to the power x are there, the exponent function. So this is the formula, and this is a question for the partial one. At first we will say let z equals to e to the power x, then dz by dx would be e to the power x and dx. On replacing it, we will get the integration of 2z by z minus 1 and 2z plus 3. Okay, so this is the formula for partial fraction. Okay, you can solve it in two way. The one way is to go to the completing the square method, or you can directly calculate the integral by using the partial one. Okay, say 2z by z minus 1 times 2z plus 3 can be written as a by z minus 1 plus b by 2z plus 3. Okay, on doing this, then the cross multiplication is 2z plus 3, and again we have b z minus 1. Okay, so putting z minus 1 equals 0, or you can say z equals 1, then we will get 2, this will be 0, and this will be 5. Therefore the value of a is what? 2 by 5. And after that, the value of, for b, let's say 2z plus 3 is equals to 0, then the value of z is minus 3 by 2. So this would be 2 times minus 3 by 2 equals, that is 0, and this one is b minus 3 by 2 minus 1 again. So this will be minus 3, again b, this will be minus 5 by 2, this would be what? This would be 6 by 5 is equals b. Okay, so on replacing this 2, we will get our required answer as, so we convert into 2 by 5, the integral of 1 by z minus 1 plus 6 by 5, obviously dz, and this one will be the integral of 2z plus 3. Okay, we know 2 by 5, this would be log mod z minus 1, and this will be 6 by 5 log mod 2z plus 3, and we need to divide it by 2, as we are having 2 as the coefficient of z. Okay, plus c, after putting the respective value of z as e to the power x, you will get your required answer. Thank you for watching. So moving to the next question. In this question, they have given us determine the cost production, the cost of, in this question they have given us to find so moving to the next question. Here we need to find the cost of producing 300 cars if the marginal cost is given. The term marginal means differentiation. Okay, and from differentiation they are asking you the cost, then we need to reverse the differentiation, and the reverse of differentiation is integration. So simply we need to integrate it, cn x integration 3x square plus n, the integration of this with respect to x. This marginal cost will become simply the cost function, and this will be become 3x cubed by 3, and this will be plus 10x. Now they have plus c would be there for the arbitrary constant, or you can say the fixed cost. Okay, now the production cost of 300 cars would be 300 to the power 3 plus 10 and 300. This would be what? 3000, and that would become 27,000, and again 20 would be there. Okay, 6 times 0 will be there, plus c. On adding this, you will get your required answer. Thank you for watching.